Welcome to This Explainer. Let's totally skip the science fiction for a minute and dive straight into the brutal, awe-inspiring reality of what it would actually take to make the red planet our second home. Okay, just picture this for a second. You wake up one morning, look out your window, and instead of green trees or blue skies, you're staring at an endless, freezing red desert, stretching all the way to the horizon. The sky? It's a striking butterscotch orange. The sun looks smaller, more distant, and outside that window, it is literally colder than Antarctica. One tiny mistake out there could end your life in seconds. This isn't a movie script. This is the very real starting point of arriving on Mars. The contrast between Earth and our potential second home is just mind-blowing. Think about our thick, protective blue atmosphere that we completely take for granted. Mars? Its atmosphere is practically non-existent, only about 1% as thick as Earth's. There's virtually no breathable oxygen. It's too thin to easily slow down an arriving spacecraft, but somehow just thick enough to create blistering, intense heat when you enter it. And navigating that thin atmosphere? Well, first you have to survive a harrowing 7-month journey through deep space. Then comes the entry heating and what space engineers literally call the 7 minutes of terror. Because slowing down is so unbelievably dangerous, one tiny error means the mission is over before it even starts. But if everything goes perfectly, the hatch opens, you take those first footsteps, and boom! Humanity officially becomes a 2-planet species. But surviving this hostile surface? Yeah. Any celebration is going to be cut really short because the brutal reality sets in immediately. Mars absolutely cannot support human life naturally, meaning every single second you spend outside your ship depends entirely on technology. Just stepping outside, you're hit with temperatures plummeting below -80 degrees Celsius. Obviously no oxygen to breathe, but the craziest part, the atmospheric pressure is so incredibly low that if you were exposed to it, your bodily fluids would actually start to boil. Throw in massive dust storms that can blanket the entire planet for weeks at a time, and you quickly realize why a highly advanced pressurized suit is your only lifeline. Now, there's also an invisible threat we really can't ignore. Earth has this robust global magnetic shield that deflects dangerous cosmic rays and solar radiation. Mars is completely missing that global shield. This leaves colonists horribly exposed. Over time, that constant radiation bombardment can damage DNA, weaken the immune system, dramatically increase cancer risks, and even mess with memory and brain function. It's a silent, deadly barrier to settling there. So, how do we actually protect ourselves from all that? Well, the very first homes definitely won't be those pretty glass domes sitting on the surface. Early colonies are probably going to be inflatable habitats, heavily buried under thick layers of Martian dirt just to block the radiation. Or, even better, settlers might build their communities entirely underground, tucked inside ancient lava tubes that formed billions of years ago. We're talking about massive natural caves becoming the very first neighborhoods on another world. Down in those habitats, absolutely nothing can be wasted. Every drop of water, every single breath of air gets filtered and recycled. Water is literally going to be more valuable than gold. But here's the good news. Mars actually hides enormous amounts of frozen water beneath the surface and at its polar ice caps. We can mine that subsurface ice for purified drinking water, and it gets better. We can split that water to create breathable oxygen and extract hydrogen for rocket fuel, which means eventually Mars could sustain itself without needing constant supply ships from Earth. Okay, moving on to farming a dead world. Because once you have water secured, the next colossal hurdle is food. There's no rich soil, no rivers, no natural sunlight. You can't just plant a wheat field out in the red desert. Martian agriculture has to be 100% tech-driven. We're talking highly advanced indoor hydroponic greenhouses. Colonists will use strictly calibrated LED lights and nutrient-rich water instead of dirt to grow stuff like lettuce, tomatoes, and potatoes. And for protein, traditional livestock is way too resource-heavy. So future settlers will likely rely on plant-based proteins, lab-grown meat, or, edible insects. They require just a tiny fraction of the resources to produce, making them a total game changer. But we really need to talk about the human toll here. Even with food, water, and shelter totally locked down, daily life on Mars is going to challenge our physical biology in ways we've literally never had to endure. It all comes down to one number: 38%. Gravity on Mars is only 38% of what we feel here on Earth. At first, that sounds awesome. Walking would feel easy, you could jump incredibly high and lift heavy gear like it's nothing, but that low gravity triggers rapid muscle deterioration and severe bone density loss. Your heart doesn't have to pump as hard, and even your vision can change. Colonists are going to have to dedicate several hours every single day just to intense exercise to fight it off. Which naturally brings up a truly mind-bending mystery about the future of our species. What happens to children born on Mars? Would they grow normally? How would their bones develop in that low-gravity environment? And the really big question, could they ever safely return to Earth's crushing gravity? Scientists honestly don't know yet. Over generations, we might literally see evolution shape two distinct branches of humanity, separated by millions of kilometers of empty space. And compounding all those physical changes is the crushing psychological isolation. Depending on where Earth and Mars are in their respective orbits, communication takes anywhere from 4 to 24 minutes just to travel one way. There are absolutely no live video calls with your family back home. No instant chatting. Every single message would feel like sending a letter into the future. Imagine waiting almost half an hour just to get a reaction to a joke or some news you shared. And in an emergency, you can't wait for mission control back on Earth to save you. Emergency problem solving falls entirely on the colonists themselves. That extreme independence means mental health and forging incredibly strong social bonds are going to be absolute matters of life and death. Yet, it's not all just hardship and isolation. Amid all these immense challenges, settlers would get to witness some of the most breathtaking sights ever. With no thick atmosphere muddying the view, the Milky Way would stretch across the sky in brilliant, unfiltered detail. They'd watch two super fast-moving moons, Phobos and Deimos, literally race across the heavens. And perhaps the most emotional sight? Earth. It wouldn't look like a giant blue marble anymore. It would just be a tiny, bright star. A constant, glowing reminder of the distant world they left behind. Looking way ahead to terraforming the future. As technology gets better, those little underground bases will eventually grow into huge domed cities. And when we reach that incredible level of civilization, humanity might just attempt the greatest engineering project in history. We're talking about terraforming. This is the multi-generational dream of slowly modifying the planet's atmosphere and temperature to make it genuinely habitable for life. It's an audacious plan to take this freezing, dead red desert and transform it into a living, breathing, warmer world. Obviously, this wouldn't happen overnight. It would take hundreds, maybe thousands of years to pull off. But here is how that epic process could actually play out over the centuries. First, we might build massive space mirrors to bounce focused sunlight right onto the surface. Then, we'd intentionally build factories just to pump out greenhouse gases and trap that heat. Step 3 is releasing frozen carbon dioxide to dramatically thicken the atmosphere. And then, centuries later, temperatures finally rise enough for liquid lakes and rivers to actually appear. Finally, the ultimate milestone, forests begin to grow. No one alive today would ever see it finished, but every great achievement starts with people willing to think way beyond their own lifetime. So, I want to leave you with this provocative question to wrap up our explainer. Will future generations look back at Earth not as humanity's only home, but merely as the place where our incredible journey began? Every single sunrise on Mars is going to demand teamwork, hardcore science, and sheer determination. But as our civilization pushes out across millions of kilometers of deep space, Mars isn't simply going to change where we live, it is going to fundamentally change what it means to be human.